Let me start with a question. If you were to buy a gift, like something to wear, for your partner, your parent, your best friend, someone you love, what would you pick and how? We would probably agree that we would have already a starting point, like we would already know whether that person would prefer a jumper, a sports suit, or an elegant shirt. And I think the same consideration would apply when picking the color. You would probably not be choosing according to your own preferences. You would rather be simulating the decision process of that person based on the collection, on the observations you have that describe the high static judgment of that person. This is a very important aspect when diving into machine learning, or at least the classic definition of it. The historical collections, the observations we have that describes our recipient are basically our data set, as we've learned from lesson number 1. But rather than focus the whole decision process on the whole data set, we're actually focusing on a sub part of it, meaning the high static judgment. As we've learned in the previous session, the observations that we have are the data we can rely on. In this video, we're going to see how this decision process looks like and what are the main components that characterize the machine learning approach, or at least the classic way of doing it. Machine learning is a field of computer science that gives the machines the ability to learn, starting from data. Within the machine learning bucket, there is a specific set of methods based on neural networks called deep learning that deserves to be treated separately. In the feature extraction, we are basically converting our initial data into a list of relevant features that can best capture the differences between two data instances. For example, let's assume we want to build an apple versus oranges, actually mandarins, classifier. What feature would you consider to best capture the differences between these two fruits? Would you consider the weight? Probably in this case that would help, as the heavier it is the fruit, the likely is going to be an apple. What happens if I have different type of apples? As you can easily see, in this case, considering the weight would not help anymore, as the two fruit might overlap. To overtake this issue, what we could do is to look for more discriminative features that can help us classify the two fruit with a higher probability. A good example could be considering the texture of the fruit. I'm sure we would all agree that the skin of an orange is completely different than the one of an apple. Since this feature is very good at emphasizing the differences between the two items, this will improve the probability for the machine to correctly identify the two fruits. Unfortunately, in most of the cases, identifying objects by relying on a single feature is not possible. The question is, how do we handle those situations and teach a machine how to take the proper decisions? One of the approaches consists in work with a list of features, so not a single one anymore, and assign to each one of them a weight value, like a measurement of relevance, so that we can capture the discriminative contribution coming from all of them. We can tell that the machine has learned how to take decisions when the algorithm will have estimated the best weight to assign to each feature in order to maximize the accuracy of the model. This is just an example of a machine learning algorithm, but it summarizes pretty well the importance of having a feature engineering steps and a decision-making steps. There are many other solutions out there, and if you'd like to find out more, please check out this link. Okay, before diving into the deep learning world, let's wrap up this session by sharing a few of the pros and cons of a classic machine learning approach. Since most of the intelligence is coming from the feature we decided to pick, most of the machine learning algorithms are not compute intensive. They can be effective with smaller data sets, and models are usually easy to explain and understand. which is a very nice thing to have in all the situations where you want to be able to track the path that the machine has taken from the input to the final answer. Since classic machine learning has been around for many years, there is also a rich literature that people can leverage to develop their algorithms. And that's why plenty of the companies are nowadays still working on this approach to develop their solutions. Please find here a few examples of them. Prediction, recommendation, content analysis, and scheduling. As you can see, most of these use cases do not rely on multimedia data such as images, video, or audio. That's because classic machine learning algorithms are not suitable for capturing complex such as non-linear relationship between data. Furthermore, on the downsides, engineering the best features, it's a really tough operation. We're not always dealing with fluids that we know very well, and spotting the most discriminative aspects when all you have is a sequence of value like the one coming from sensors distributed in a manufacturing pipeline can be extremely challenging. Alright, I hope you enjoyed this video, but before leaving, I would like to ask you a question. Do you know why a guitar can help understanding deep learning? Well, come and find that out in the next video.